Okay, welcome. We're going to go through some examples on how to find zeros of different polynomials and then how to graph them, okay, using end behaviors and multiplicities. So, without further ado, let's go through one. Let's say I gave you a function, f of x equals x, and then we have x plus 3 squared, okay, and I want to graph this polynomial. The first thing we want to do is we want to find the zeros, okay, and we want to find the zeros. And because our eventual goal is we want to graph without a calculator, because I want to graph without my calculator, graph this polynomial. Graph the polynomial. All right. So we're going to first find the zeros. So that's pretty easy. We're going to set this equal to 0. And when we find out our x0 is going to be a 0 and -3. Now, when we do this, we're going to now plot my zeros, okay, right here. And we have our 0 at 0. And then we got -3, 1, 2, 3. And we have that. Now we're just going to sketch the graph of this. If we want to do a better sketch, we have to plug in some additional points to figure out how the curve moves. But we can get a basic understanding of this by now looking at the graph itself. We realize that this 0 right here at 0 has a multiplicity of 1. The 0 at -3 has a multiplicity of 2. Multiplicity means the 0 is being used twice. I had other tutorials explaining this, but the multiplicity is 2. So by that, adding these together, or if you multiply this out in general form, we know the degree of this polynomial is going to equal 3. Now, it's important to know that this is a third degree because that will help us determine the end behaviors. The end behaviors, if you recall, if you watched my other tutorials, all right, are what happened to the graph as where does y go? Where does y go as x approaches infinity and when x approaches -infinity? So two ends of the graph, where do they go? Do they go up, down? All right. Do they approach an asymptote? What happens? So with that, we know a third degree polynomial, all right, with a leading coefficient, and the leading coefficient here is positive. All right, third degree leading coefficient is positive. All right, so it's still positive right there. With all this information that we have, we can now say that this graph is going to rise to the right and fall to the left. Okay? Now, from here, we start on the left-hand side, and we go and approach this first 0, which is at -3. Since this 0 has a multiplicity of 2, we know that 2, or an even multiplicity, makes to the graph that it's going to touch the graph or is tangent to the graph, and it comes back down. It then comes back up through this 0 right there, all right, because at 0, we have a multiplicity of 1, which is odd, where it passes through. And this would be the sketch of our graph. Okay? We can also perform a sign chart, okay, and going through and figuring this out. By using the sign chart, we can get the same thing. We take our zeros right here, and we got a 0 at -3 and 0. We write our intervals from -infinity to -3, and from 0 to infinity, and then we got 3 to 0. By using, oh, sorry, -3 to 0. And looking at our y values. So what is the sign of my y? This is a sign chart, by the way. You didn't know. Just check it out. All right. Is that we plug in a value. So I plug in like x equals -4. When I plug in x equals -4, this is my one end behavior. So over here, I plug in -4. I plug this back into my factors. Easiest, I get a negative for my first factor right here. And then I plug in -4. I get a -1 squared, which makes it positive. So negative times a positive is a negative. And that's why you see this going down. We go to the next one. We can plug in -1. Easy. Plug in my first vector. I get negative value. Plug in this one. I get a positive value. Once again, you can see that it's going to be negative, and it's going to be down. And that's why we verify that it is tangent, because we do have a multiplicity of 2. Our last one, we can plug in 1 or any other value on this interval. Plug this into our function. We get a positive value because it's 1. We get a positive value. It's going to be 16, which is another positive. And positive times a positive is positive. So it's positive that it's going up. And that would be our sketch. To find out additional points, put in your calculator, graphing calculator, or just plug values into the function to generate those. Okay. So we're going to do one more. Okay. Find the zeros in graph. For this one, we're going to have one where we actually may have to do a little bit more work. We're going to have g of x, and it's going to be x to the 4th minus x cubed minus 2x squared. And in this problem right here, what we're going to do is we want to once again graph it. So our goal is to graph the polynomial, okay, or sketch the graph of it. So the first step in graphing it is find the zeros. So we have to find the zeros, okay, because those are critical points. So we're going to set this equal to 0 again, and let's find them. We can factor this, and we have x squared coming out, and we have x squared minus x minus 2. This appears to be factorable. Actually, I believe it is. It's got -2, and we get x plus 1. And now we can look at our factors and identify our zeros. So our zeros in this case are going to equal 0. We got a 2, and we got a -1. This is not in correct order. You'd have to flip this around, get that in the correct order. Now from here, I'm going to identify the multiplicities. A multiplicity, I am using this x value twice, so I have actually a double root, or a multiplicity of 2, because 0 is being used twice. Here I have this factor is used once, so my multiplicity for this 0 is 1. Right here, this factor is used once as well, all right, and so I have a multiplicity of 1. 2 plus 1 plus 1 is going to equal 4, so I know I have a degree of 4th degree, okay, because the sum of the multiplicities equals the degree. So I have a 4th degree polynomial. All right. Knowing that I have a 4th degree, we then know something about our end behaviors. I'll first graph my zeros though. I got 0 here, I got 1 at 2, I got 1 at -1. All right. Got those zeros there. Now, my end behaviors. And behavior is the next thing I'm going to graph. Because it is a 4th degree, it's just like a quadratic, a 4th degree, all right, that has a leading coefficient, which is positive right here. And it is positive. I'll get rid of that because I don't want to have that. So leading coefficient is positive. Means that to the right, it will rise, and to the left, it will rise also. Okay, so we rise both to left and right. Because once again, all right, so rise to the left and rise to the right. Okay. We can now go and do our curve sketching using the multiplicities. We come right here to our first value. I start left to right, left to right. We come to -1. Look at -1. That has a multiplicity of 1. So that means we pass through. Multiplicity of 1 means passes through. Come back to the next 0. We look at 0. Make sure you look at the correct 0. We look at 0. 0 has a multiplicity of 2. So that means it's going to be tangent. So it's going to come back down. And then we come up to this next one. And obviously, I'm guessing it's going to be an odd or an even 1 right there. Okay, which it is. So it passes through, and that's our sketch. Okay, we can do a sign chart if we so choose. And by doing a sign chart, we can plot in order the zeros. Okay, -1, we got 0, and more, 2. We have our intervals from -infinity to -1. That will tell us our end behavior. 2 to infinity will be also our end behavior. -1 to 0, and then 0 to 2. Looking for our y values. Plug in x equaling -2 into my factored form. This right here will give me a positive value. This right here will give me a negative value. Negative value. And then this right here is going to give me a negative value as well. Positive times a negative times a negative. It gives me a positive, and my graph is going to go up. All right. Over here, I can plug in, I don't know, -1/2. Square it. Gives me a positive value. Plug it in here. It gives me a negative value. Plug it in here. It gives me a positive value. And so a positive times a negative times a positive gives me a negative value, which means it's going down. We can plug in now a value in this interval. Plug in here, you get a positive number. Plug it in here, a 1 gives you a negative number. And then plug in there, you get 2, which is a positive value. And negative times positive times a negative times a positive is negative. Negative. And so it stays down. And then finally, plug in a 3 or any number in the interval, and you should get a positive, and positive, which gives you a positive value going up. Okay? So In short, there are many different ways to graph or sketch graphs of polynomials. The key thing, though, you have to find first is always find the zeros through factoring, or if it's factored already, write them out. Next thing is you want to know the degree. Okay, to help you find the degree, take the sum of the multiplicities. All right, sum of multiplicities to get you the degree. All right, and that will tell you the, and using the NB, or leading coefficients, that will help you find the end behaviors, which you graph. All right, and then using the multiplicity, you can determine how the curve goes. Or a sign chart is always great as well. All right, so those two are different examples on how to graph polynomials. Hope this helps, and God bless.